Hi everyone, in this video I want to introduce to you how to use the Lerdge-iX 3D printer. Before this, you need to complete the assembly and calibration of the printer. If you haven't finished yet, you can watch these two series of videos. Follow our next steps and you will easily learn to use the Lerdge-iX 3D printer. 1. Turn on the 3D printer. Before turning on the power, please repeatedly confirm the correctness of the board wiring and power supply wiring. If the wiring is incorrect, the board may be burned or the power supply may be damaged. The power supply used by Lerdge-iX can support 110V or 220V input voltage. Before turning on the Lerdge-iX for the first time, you need to put power input voltage switch to the correct gear according to the local mains grid voltage. Remember, be sure to select correct gear, plug the cable into the machine's main power socket, and then turn on the power supply. At the same time, the power indicator light lights up. Press the metal switch on the side of the display for 1 to 2 seconds to ensure that the machine is powered on successfully. 2. Introduction to the main interfaces. In order to facilitate these guys who are new to Lerdge printers, I will first briefly introduce the functions of each icon on the main interface. These two are the hothead and hotbed icons. Click the icons to turn on or off the heating of hothead and hotbed. The three icons in the middle are the homing icons for the X, Y, Z axes. The numbers indicate axis coordinates. The one on the bottom left is the setting icon. Click it to enter the setting interface. There are many menu options in which you can modify various parameters. You can slowly study these parameters after becoming familiar with them. We do not recommend that novices modify parameters. The middle one is the print icon. Click to select print files. Transferred from USB flash driver, TF card or Wi-Fi. The one on the far right is the control icon. Click to enter the control interface. For the control interface and printing interface, I will not introduce them in detail here. You can naturally become familiar with them quickly by combining these two pictures with the actual printing operations. 3. Check the temperature of re-hot end. Next, we check the temperature measurement functions of the hothead and hotbed. In front of thee is the current temperature of the hothead and hotbed, and behind thee is the target temperature. At this time, the target temperature is 0, which means that we have not turned on the heating of the hot end. Now I click the hothead icon, the target temperature becomes the preset 210, heating is turned on, and we can see that the real-time temperature of the hothead is also increasing. Click the hothead icon again to turn off the heating. The target temperature becomes 0, and the hothead will naturally cool to room temperature. Without initial heating, the hothead and hotbed temperatures should be approximately the same as room temperature. If the difference is too large or the real-time temperature automatically rises when the hot end is not heated, please turn off the printer in time and refer to the FAQs on the Lerdge official website to solve this problem. 4. Check the end-stop function of each axis. Firstly, let's check the X-axis end-stop. This is the X-axis end-stop, and we move the print head to trigger it, and observe whether the X-axis icon on the display changes from the positioning icon to the house icon. Pay attention to observe triggered, the house icon removed, positioning icon. In the same way, we check the Y-axis end-stop. Here is the Y-axis end-stop. Moving the printing platform backward to trigger it, the Y-axis positioning icon changes to a house icon. Remove the platform. It changes back to the positioning icon, which means that the Y-axis end-stop is normal. Next, let's look at the Z-axis end-stop. It is an optical end-stop. Find an opaque sheet, for example. I used tweezers. Inserted it into its optical slot. The green indicator light will light up and the positioning icon on the display will become house icon. Remove the sheet. the green indicator light goes out and the house icon changes to the positioning icon, which means that the home function of the Z-axis is also normal. 5. Check the function of motor. Manually rotate the screw rod, raise the X-axis arm, and move the print head and the hotbed to the middle position by hand so that the distance between the nozzle and the platform is more than 10 m. Then enter the movement control interface and click the middle icon to modify the unit movement distance. It is more appropriate to set it to 10 to 30 mm. At this time, click the end of each axis in turn. Note that you need to click and then on any axis. When you click X, the print head should move to the right. When you click X, the print head should move to the left. When you click Y, the heated bed should move forward. When you click Y, the heated bed should move to the back. When you click Z, the arm should move upward. When you click Z, the arm should move downward. When you click E, the extrusion gear should rotate counterclockwise. When you click E, the extruder gear should rotate clockwise. If the movement of each axis of your machine is consistent with the video, it means that the motors of each axis are functioning properly. 6. Adjust the Z-axis origin position. Next, we adjust the origin position of the Z-axis. That is, adjust the distance between the nozzle and the platform after the Z-axis homing. The trigger baffle on the Z-axis homing adjuster can be extended or shortened. Manually rotate the screw rod to lower the X-axis arm. At this time, carefully observe the distance between the nozzle and the platform so that the distance is about 1 to 3 mm. Keep the arm unchanged and loosen the screw on the homing adjuster. Adjust the trigger baffle so that the optical end stop is just triggered, that is, the green indicator light is just lit. Then tighten the screw. We manually rotate the screw rod again for inspection, raise the arm, lower it again, trigger the optical end stop, and check the distance between the nozzle and the platform. The distance is now about 1–2 millimeters. Let's do it again. Pay attention to the green indicator light and the distance between the nozzle and the platform. Manually rotate the screw rod to raise the arm. Now let's click the Z-axis homing icon on the display. We can see that the print head is just 1 to 2 m above the platform after Z-axis homing. This means that the origin homing setting we just made was successful. For the Z-axis home position, the ideal situation is as just demonstrated. When the optical end stop is triggered, the nozzle is just 1 to 2 m away from the platform. In addition, there are two situations. One is that when the baffle triggers the optical end stop, the nozzle is too far away from the platform, which will cause subsequent leveling trouble. Another method is that the nozzle has already touched the platform and the baffle has not triggered the end stop. At this time, the board cannot receive the home signal and it will keep lowering the Z-axis, causing the nozzle to continue to squeeze the platform, eventually damage to the printer. Therefore, correctly adjusting the Z-axis origin position plays a very important role in printing. We cannot click the home icon on the display to perform Z-axis homing as soon as we get started. We can perform Z-axis homing through the display after completing the above home position settings. 7. Home each axis. Click the position icons of the X, Y, and Z axes in sequence on the main interface. The system will perform separate homing for each axis. That is, the pulley of each axis will first move in the direction of the end stop, trigger the end stop, and then move in the opposite direction by 5 mm, and then move towards the end stop again at a slower speed, and finally stops at the position where the end stop is triggered. Values below the icons of each axis on display change to the specific origin coordinate position values. After homing, each axis is locked and cannot move. You need to click to unlock the motor on the control interface. 8. Check the travel space of each axis. After homing each axis, we enter the movement control interface again. Set the unit movement to a number greater than 180, such as 200. Click X, Y, X, Y, Z, Z in sequence, and observe the movement of print head, printing platform, and arm. Pay attention to whether there is insufficient movement distance or wrong movement when moving. If each axis can effectively complete the 180 mm travel space without error, then the travel space of each axis is okay. 9. Level the printing platform. Next, we will perform leveling, which is an important operation that must be performed when every printer is used for the first time. The leveling effect also determines the quality of the first layer of printing. Firstly, enter the leveling interface. The icon on the left is automatic leveling, and the icon on the right is manual leveling. Remember not to click automatic leveling because the current printer is not equipped with an auto leveling sensor. Clicking will cause the print head to hit the platform, causing damage to the machine. Now we click on the manual leveling icon. The printer will first perform the homing of each axis, and then the print head will move to the first leveling point. At this time, we can see that the nozzle is a certain distance from the platform. Clicking and can increase or decrease the distance between the nozzle and the platform. Clicking the 3 numbers below can change the unit distance of the print head moving up and down. We can first select 0.1 mm. Click to reduce the distance between the nozzle and platform until the nozzle just touches the platform. At this time, click the right icon to adjust the next point. The method is the same. We can clearly see the distance between the nozzle and the platform with the naked eye, and can make the nozzle just touch the platform by or adjustments. Use the same method until all 4 points are leveled. Note that after the 4-point leveling is completed, be sure to click the right icon again to end, so that the data just adjusted can be saved. 10. Check the leveling effect. We first enter the leveling control interface. You can see 5 position icons on the left. Click these 5 icons in sequence, and the print head will move to the corresponding 5 positions on the platform. We need to check the leveling effect of the 5 positions in sequence. The ideal state is that the nozzle just touches the platform at each position. You can see that the nozzle just touches the platform at this position, and there is no problem with the previous positions. But in the last position, there is a slight gap between the nozzle and the platform. A slight difference in 1 or 2 points like this is relatively normal. After all, the leveling process in the previous step was a human judgment. At this time, we can click the "and" here to fine-tune the Z-axis. Note that the current adjustment is the overall adjustment of the Z-axis, not a single point adjustment. If the difference between the 5 points is relatively large, the printer needs to be re-leveled. 11. Preheat the print head and hotbed first. Manually rotate the screw rod to raise the X-axis arm, and try to ensure that the nozzle is at least 5 mm away from the printing platform. This makes it easy to observe the extrusion of filament from the nozzle or to clean the nozzle. Then return to the main interface and click on the hot head and hotbed icons to turn on the heating. At this time, you can see that the real-time temperature in front of thee is rising. 12. Load filament. When the hot head temperature reaches above 200, we can load the filament. First, cut a bevel on the filament and insert the filament into the extruder through the plastic opening. The filament should be inserted into the extruder wheel. The green indicator light on the side of the extruder should light up. Enter the control interface, click the filament icon, and click under the auto option. The printer will automatically load the filament into nozzle and squeeze out a small amount of excess filament. It is worth noting that if we have clicked to auto-load filaments once, but the filaments are not loaded in place, do not select auto loading again at this time, as this may cause the damage to the extruder. At this time, observe the position of the filament in the plastic tube and click auto to switch the single loading length to 1 mm, Air 100, and select the appropriate value to load the filament again until a small amount of filament flows out of the nozzle. 13. Start printing the first model. Now we can start printing. When printing for the first time, we recommend using Lerdge test file for printing. Go to Lerdge official website and iX usage tutorial. Download the sliced 3D Benchy 54min.g code on this page for printing test. After decompressing the file, copy the TXT file to the root directory of the USB flash driver or TF card. Then insert the USB or TF card into the printer, click the Start Printing icon in the main interface, select the corresponding USB or TF card. Note that under this menu, directly clicking the file name on the touch screen has no effect. You need to click the up and down arrows on the right to select the file. Select the 3D Benchy 54min.g code. We just put in, but once the hot head and hot bed have reached the target temperature, the printer will start printing. 14. Fine-tune the Z-axis for the first layer. The first layer plays a vital role in the success of printing. Although we have already performed leveling before due to lack of experience at the beginning, so when we printing the first layer, we can fine-tune the overall compensation of the Z-axis according to the adhesion state of the filament extruded from the nozzle on the printing platform so that the first layer printing more perfectly. Enter the Z-axis fine-tuning interface. Clicking can to increase the distance between the nozzle and the platform. Clicking can reduce the distance. Clicking the middle value can switch to 3 levels 0.01 mm, 0.05 mm, and 0.1 mm. The value next to the print head icon is the adjusted value. In order to let you guys better understand what the most appropriate state should be for the first layer of printing, I specially prepared another clearer model, which is a great circle. Now the printer is printing the first layer of the big circle. Let it print for a while.
1 hour later.
We can see that the filament can adhere to the platform perfectly. This state means that the distance between the nozzle and the platform is just right. I slightly increased the distance between the nozzle and the platform, and then take a look at the printed effect.
2 hours later.
We can see that the filaments cannot stick to the platform, and the edges are still warped. This is the effect caused by the distance between the nozzle and the platform being too far. Finally, if we lower the distance, we will find that the extruded filament becomes thinner and the first layer is not smooth.
3 hours later.
In this area, the distance between the nozzle and the platform is the most suitable, and the printing will fit smoothly. In the second area, the nozzle is too far away from the platform and the first layer cannot stick to the platform. In the third area, the nozzle is slightly far away and the first layer is not very firmly attached. In the fourth area, the distance between the nozzle and the platform is too small and the hand layer is peeled and uneven. In the fifth area, the nozzle is closer to the platform and the filament is difficult to squeeze out of the nozzle. Excessive squeeze between the nozzle and the platform may cause damage to the printer. According to the entire printed circle, the distance between the nozzle and the platform must be appropriate so that the printed model effect will be perfect. Returning to the benzene we just printed, its first layer seems a little too tight now. I click to slightly increase the distance between the nozzle and the platform. Be careful not to rush to operate frequently during the fine-tuning process to avoid excessive adjustment. Through Z-axis fine-tuning, we can get a high-quality first layer. After closing the fine-tuning window, the Z-axis adjustment data will be automatically saved, and there is no need to adjust it again next time you print. 15. Pause. Stop and resume printing. If we need to pause during the printing process, just click the pause icon in the printing interface. At this time, the system will first lift the print head 2 mm, then move the print head to the left front position of the platform and pause printing. At this point, we can change filament or other operations. Click the continue icon to resume printing. If we need to end printing during the printing process, click the stop icon and a pop-up will appear asking whether to save the printing progress. Clicking will end printing and save the printing progress. Do not move the Z-axis before continuing to print. That is, you cannot change the height of the nozzle to the printing platform, otherwise the height of the model will be wrong when printing is resumed, resulting in printing failure. But you can move the print head and printing platform in the X-axis and Y-axis directions. When you select the file name of the model you just printed again, the system will pop up a window to continue printing from the last time. Select to continue. When the temperature reaches the target temperature, you can continue to print the model just now. 16. Automatically shut down after printing. If you don't want the printer to remain on after printing is completed, you can enter the control interface during the printing process and check the option Turn off the printer after completion. This way, the printer will shut down automatically after the printer finishes printing and cools the hot end to room temperature. Now that we have initially learned how to use Lerdge-iX, please follow us. In the next video, we will spend 3 minutes learning how to download the slicer, configuration of slicer, and find our favorite model. Okay, that's it for today's video. See you in the next time.